Yes, good afternoon again. Just the way I said, I'm teacher Stephen Monde. I would like to teach on how to fill the table for the titration. That is paper 3. Paper 3 has 3 questions usually. The first question comes from the quantitative analysis. The quantitative analysis it involves the calculations. I mean, you have to get the quantity of something. Again, we have got the part 2, which usually come from inorganic. That is number 2, usually come from the inorganic. That is moisture under salt. So that one also, if you want to understand salt, kindly make sure you understand the form 2 salt very well. That is the key. From there, read form 2. Like all nitrates are soluble. You should know that. You should know that as a student. It's a very much important. All those salts, read them, how to prepare the salts, insoluble salts and soluble salts, all the types of preparation of salts. Salt is a very crucial topic that you have to understand. Hate me now, but love me in future. Make sure you read salt and understand salt as a topic. Combine it with the salt in form. And as form 4, you can see even under that salt, it can also be tested as a quantitative analysis when we are now dealing with what we call the solubility. You see that? So the salt is very much crucial topic. So kindly begin from form 1, form 2. Read that salt very well. Read it as if you will never read it again. Read it as if you are told that if you don't read, you are going to die in the next 20 minutes. So read not to die. Thank you. So how the last bit of the chemistry practical is under the organic. Sasa organic is now the easiest qualitative analysis that I've ever seen, and in fact it is the question that they usually bring less marks into that, because I don't know whether they know that it is easy, but it is a challenge to so many students, being that most of the students are afraid of organic chemistry as a topic, even in form 3 and form 4. Thank you. So the one that I want to talk about is under the moles, how to fill the table only. That is what I want to discuss today. Table has 3 parts. We have the first attempt, second attempt, and the third attempt. That a student should do the 3 and write the titer values that she or he has obtained from the titration. We have so many types of titration. We have direct titration, we have redox titration, and also we have there are 3. So here, let us talk only on how to fill the table. The table has, just the way I've said, it has I don't know whether you will see it. It has 3 parts. So for a student not to get confused, the first row The first column, the first column, it is usually for the the final value. Then in the column third column we have the initial value. Then the third column we have the volume used. So before you do anything, after filling the burette read from 0 to 50. To mean you fill the burette with the liquid that you have been, with the solution that you have been given, or the one that you have been told to fill the burette with, up to 0 mark. To mean your initial reading will be at 0 mark, and that is what you will fill here. So when filling the table, there are things that you have to understand. Table is 4 marks. 1 mark will be just for completely filling the table. That is C. Completely filling the table. You will only earn that 1 mark if you fill the table with realistic values. Why do I talk about the realistic values? We have unrealistic value. We have unrealistic values. We know that the content of the burette should be from 0 to 50. To mean, if you get any value which is more than 50, like 51, 60, 70, 80, those are unrealistic values. Or you get negative 1, negative 3, negative, the values which are not within 0 to 50, automatically everything will be wrong. So what you have to know, filling the table with realistic values. So the values should be within 0 to 50. Again, when you are filling the table, again, you have to talk about the consistency. In the consistency, now we talk about the number of decimal places. The number of decimal places that you are going to use. If you have chosen to use 1 decimal place, use it throughout the table. In that, don't come with, you get another value 20.225, another one 20.5, another one 20. No, use consistent number of decimals throughout this table for you to earn the second point, which is consistency. Fill the table with the same number of decimal places. If you have chosen to use 1 decimal places, make sure you use it throughout the titration. Again, if you have chosen to use 2 decimal places, make sure the last digit should be either 0 or 5. That is 20.25 or 20.20, 20.35, 20.30. Yes, but don't come with 20.31, 20.32. No, the last digit should be 0 or 5. If you have chosen to use 2 decimal places and use it throughout the journey here is filling the table. So I think everything will be okay. Again, that is that. Don't use 3 decimal places. Kindly use either 1 or 2. Don't use 3 decimal places. Use either 1 decimal place or 2 decimal places. Sawa. Again, another mark that we usually give here is now on the filling the table we have talked about, consistency we have talked about, and again now the accuracy, the third mark. Accuracy comes, when the practical is being done. If at the KCSE level, your teacher who is teaching you chemistry will also do the practical, but we will only fill the table, but will not do any calculation. So don't celebrate that the teacher will give you something. No, we don't do that. The teacher will be given a room under supervision, and will not use the same question that the same question paper. He will not write those things on a question paper. He will be given a booklet to fill. So don't celebrate. So accuracy comes when your values, one of the value in the volume used can be found within the school value, which will be made by the teacher. Your teacher will make that, which will be used in marking for the school value. So maybe your values, the volume used, you have gotten 25.25, another one is 25.20, another one is also 25.25. So the first one is 25.25, another one is 25.20, another one is 25.25. So I've used 2 decimal places. So when the teacher did the practical and got the values, his values, maybe also he got maybe 25.25, another one is 25.25, another one is let's say 22.25, 25.25, the teacher's values, 25.25, 25.20, I mean, and also 25.20. So what the teacher will do here first, what the markers will do, they will compare. So if any of your value is within the teacher's, if any of your value is within any of teacher's value in the range of 0 positive or minus 0.1, you get a mark. Or if your value is within 0 positive or minus 0.2, you also get no, because we have used the teacher's value is within 25.25. We have used 2 decimal places. So if your value is within 0 positive or minus 0.002, you get a mark, or positive or minus 0.01, you get a mark, because the decimal places here that we are using is 2 decimal places. So we have to consider the sympathies values. So your value should be in the range of positive or negative 0.02 when we are talking about the 2 decimal places. But when we are talking about the 1 decimal places, if the school value is 1 decimal places and you also there, then it is okay. when you talk about your values should now be within 0.01 or 0.02, then you get the mark. So if any of your value is within the school value, within that bracket that I've talked about, if one decimal places, that is 0, positive or negative 0.2 or positive or negative 0.1, then you will, that value which is within that range, it will be marked and you will get that mark for accuracy. Again, now we are coming to the last bit. Here is now the principle of averaging. Principle of averaging. That one will come in the first question that will be used to calculate the average volume used. So what you will use, take the values which are in the bracket of positive or negative 0.2. Are we together? Take the values which are inside 0.2, positive or negative 0.2. Let's and be very keen. Let's talk about this one. We have 25.5. Another one we have 25.3. Another one we have 25.2. So the first one we have 25.5. Another, the second one we have 25.3. The third one we have 25.2. Check the first value and the second value. Is it in between 0, positive or negative 0.2? Check 25.5 minus 25.3. You will get 0.2. You will get 0.2, which is inside. It is within that bracket that we want. Check it with the last one, that is with the last one, that is 25.5 minus 25.2. You will get 0.3, which will not be in that bracket. Check the second one and the third one, which is 25.3 and 25.2. You will get the difference between there is 0.1. Are you seeing that? So the first one and the last one are not in the within the bracket of what? Positive or negative 0.2. So what do? We cannot use the first one and the last one at the same time. Are we together? So either you can use the second one and the third one, that is you add 25.3 plus 25.2, then you divide by 2. Then you divide by 2, not 3. I know some have crammed at everything is being added, everything are being added and you divide by 3. Or some have crammed that everything must be divided by 3. No, my learned student, don't dare to cram chemistry. Understand the concepts which are being told, you are being told by the teacher. Teacher went for a thorough training for 4 years. Some have gone even more than that. So now let us check. You can also take the first one, the first and the second. You can take the first and the second, that is 25.5 and 25.3. Then you divide by 2. You add them, then you divide by 2. You will get you will get a half. So that is why I'm also coming. You know that if your answer, or if you know that your school, your titration, the titer valve, the titer used, the volume used, are in the bracket of 0, positive or negative 0.2, you get a half. But if it is within 0, positive or negative 0.1, you get complete 1 mark. You have to know that, my student. So those are. And when can we now use the 3 titer values? Assume that we get one 25.4, another one we get 25.5, another one we get 25.3. you can check. The first one is 25.4, the second one is 25.5, the third one is 25.3. And now check the first one and the second one. The difference there is positive or negative 1. The first one and the last one, that is 25.4 and 25.3, is also 1. The second one, which is 25.5, and the last one, which is 25.3, the difference there is 2. So to mean all values are within the range of positive or negative 0.2. What you do, my friend, add those things, divide by 3, and don't forget to write the unit. Don't forget to write the unit at the last of it. That is cubic centimeters. You have to write it, and the number of decimal you have to include. Don't write a whole number. Make sure your value has got a decimal. Whether it is 25, write 25.0 cubic centimeters. Otherwise, thank you. Enjoy, subscribe in my YouTube, and you will learn many things. Thank you. Have a nice time.